This is a video presentation of Chapter 2, Section 8, Least Common Multiple. Our objective here is to find the least common multiple of two or more whole numbers. So let's start off with definitions here. Multiple. What is a multiple? A multiple, that's the product of any number and a non-zero whole number, is a multiple of that number. Multiple defined is the product of any number and a non-zero whole number is a multiple of that number. So, what you want to be thinking of multiples is, think of a times table. For instance, if I said, give me the 4 row of a multiplication table. Well, you would start off with 4 times 1, which is 4, and then you would give me 4 times 2, which is 8, and then you give me 4 times 3, which is 12, and then 4 times 4, which is 16, and you keep going. 20, 24, 28, 32, 36, 40, 44, 48, and so on. Those are multiples. The mistake people make when we get to this section is they still want to do factors like we did in 2-7. And we're not doing factors, we're doing multiples. So, now we know what a multiple is. Now let's figure out least common multiple, which should be pretty obvious. That's the common multiple with the least value. So the problems are going to look a little bit like 2-7 in that they're going to give you 2 numbers, 3 numbers, 4 numbers, and they're going to say, what is the least common multiple of these numbers? And one of the techniques you can employ is to list the multiples of each of those numbers and find the smallest number that hits on both lists. And it would then be the least common multiple. And so that's why they're saying the common multiple with the least value. We list the multiples, find the smallest one that's on both or all the lists, depending on how many numbers we have, and that is the least common multiple. Okay, so let's take that knowledge with us here into number 1, and that's exactly what they're doing. They're having us find the least common multiple by listing multiples. So, the first thing we have to do here is actually list the multiples. So, find the least common multiple of 2 and 7, list the multiples of 2 and 7. So, 2 lists, that's pretty easy. 2, 4, 6, 8, 10, 12, 14. Realize what this is. 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, 2 times 6, 2 times 7, and so on and so forth. 7 list, 7, 14, 21, 28, 35. We could keep going, but the reason they've stopped is because they've encountered a match. But again, just to be clear, realize what this is. 7 times 1, 7 times 2, 7 times 3, 7 times 4, 7 times 5, and they would continue if they needed to. Now again, we're trying to find the smallest number that's in both of the lists, hence the least part. Well, the smallest number that's in both of the lists is 14. So the least common multiple is thus automatically 14. All right, same technique, but more numbers now, 3, 6, and 9. All right, so they're going to have you now list the multiples of 3, 6, and 9, and then you're going to spot the smallest one that's in all of the lists. So the 3 list, 3, 6, 9, 12, 15, 18, 21. If for some reason you're still not seeing this, realize after you start with the initial number, they just keep adding that number. Add 3, add 3, add 3, keep adding 3. 6 list, 6, 12, 18, 24, 30. Start with 6 and keep adding that number. Add 6, add 6, add 6, and continue. 9 list, 9, 18, 27, 36, 45. So start with 9 and then just keep adding 9 to get to the next number. Okay, so we've shown that work. Now again, we're just trying to identify the least common multiple, the smallest number that's on all 3 lists. All right, well, the smallest number that's on all 3 lists here is 18. Now realize if we kept going, would there be another number that's on all the lists? Absolutely yes, 100% for sure. There would be another number that's on all the lists. All right, as a matter of fact, that number would be 36. That's just a common multiple though. Remember, we're finding the least common multiple. the smallest one that's on all of the lists. And that's why 18 is the answer. All right, now it should come as no surprise to you that there's another way to do this. And this is another place where people get confused, because what we can do is we can actually use prime factorization to find the least common multiple. And this is where people really start to go, what? We're using something that involves factors, but we're doing multiples. Yes, that's exactly what I'm telling you here. All right. In this question, they're asking us to find the least common multiple of 60 and 130. So you're going to start off here with this other technique, and you're going to do the factor trees, the prime factorization for those two numbers. Now, I know we did that in greatest common factor, but let's review it quickly here in least common multiple so you don't necessarily have to jump back to that presentation if you've forgotten. Remember, factorization, prime factorization, is a branching diagram. And you finish with a branch when you have a prime number there, a number that's divisible only by 1 and itself. Each branching is a product of the number directly above it. Okay? So, for instance, with this number here, 60, we've got lots of options, but I'm going to go with 6 and 10. Now, when I say lots of other options, realize there's other numbers that multiply together to make 60. 2 and 30 is a feasible option. 5 and 12 is another option. 3 and 20 is another option. You can pick any set you want. The end result will be the same. However, sometimes it might be a little more or a little less work depending on what you pick. Again, a branch is done when you have a prime number. Well, neither of these are prime numbers. So I'm going to keep branching this down here and keep going. So 6, well, way to make 6 is 2 times 3. And now that branch is done because 2 and 3 are both prime numbers. So that whole left side is done. 10 is going to be 2 and 5. And now we're done with that branch because those both are also prime numbers. And as you can see, what we've circled there matches the numbers they have listed here for the prime factorization in the multiplication question. Remember, you can always check to make sure this works. Just multiply this back together. If it doesn't come back to make 60, you did something wrong. The only other way you could screw that up and still get 60 is if you had a composite number there. All right, 130 would be 13 and 10. 13 is prime, but 10 isn't. 10 breaks down as 2 and 5, and those are both prime. So we've got 2 times 5 times 13. All right, stay with me. All right, now you're going to circle what's in common between the two rows here. All right, so you've got a set of 2's and a set of 5's. All right, and again, this is still looking like greatest common factor. All right, next step, pick a row. Top row, bottom row, doesn't matter. All right, I'm going to pick the top row. Okay, and again, still looking like greatest common factor. Here comes the difference, this next step. Now what you're going to do to find your answer is you're going to multiply together what you circled in that row with everything you didn't circle. Doesn't matter where it is. All right, you multiply together one row of the circles with everything you did not circle. Okay? So in this row, I circled 2 and 5. So to come up with my answer, I have to multiply together 2 and 5, which is what they're showing you there, with everything they did not circle. Doesn't matter where it is. So I didn't circle this 2, and I didn't circle this 3, and I didn't circle this 13. Well, there's the 2, and there's the 3, and there's your 13. And that's how we figure out our answer. We have to multiply all that together now. So I start multiplying here, and I've got 2 times 2, which is 4, times 3, which is 12, times 5, which is 60, and 60 times 13 is 780. And that's your least common multiple. So the least common multiple of 60 and 130 is 780. All right, here they have us doing this again. All right, we're finding the least common multiple of 14, 35, and 49. As you can see, they did the prime factorization, and they're really simple here. 2 times 7, 5 times 7, and 7 times 7. They're all prime numbers. We can see the products clean as day, so I'm not going to sit here and spend time making factor trees to prove it. Right. Again, you're going to circle now what's in all of the rows, all 3 rows. And that's just a 7. Pick a row, top, middle, or bottom, doesn't matter, you got to pick one. I'm going to pick the top. You're going to multiply together what you circled in that row, which is 7. That's what they're showing you right there, with everything you did not circle. I did not circle the 2, I did not circle the 5, I did not circle the 7. Again, it does not matter which row it is in, it's just got to be not circled. So 2, 5, and 7, we'll look at our answer row, 2, 5, and 7. So now I'm going to multiply. Multiply that together, that's my least common multiple. So I've got 2 times 5, which is 10, 7 times 7 is 49, 49 times 10 is 490. So the least common multiple of 14, 35, and 49 is 490.